This is 8-4, day 2. I just gave it to you. Grant? Yeah, but we're going to do this right now. Now, this is, and it shouldn't take you very long to write it up if you haven't done it. Okay, Duncan. This is the alternating series estimation theorem. We aren't doing too much with estimation theorems, but this one's big on the exam. When they do the free response, not 100%, but probably about 95% chance that you will have an alternating series estimation theorem or you'll have a Lagrange error bound. You hope it's not Lagrange, you hope it's this, because this is easy. Okay, this is an easy one. You'll find it hard to begin with, but you're going to run into this. Now, this is only for alternating series. And it was on last year's exam. We saw a lot of, if I graded this, a lot of Lagrange error bounds, but that's not what it was. It was alternating series. Now, do you remember what you have to have an alternating series? You have to have the alternating sign, which is the -1 to the n. The limit of the sequence without the signs as n goes to infinity must go to 0. That's always true for any series sequence. The limit of the sequence must be 0. That's a sequence. So anytime you get a series, always check the sequence. I don't care if it's alternating sign or not alternating sign. Always check the sequence, because if it's not 0, you're done. Right, b sub n plus 1 must be smaller than b sub n. In other words, b sub n must be decreasing. But they're not going to fool you. In fact, last year, they even said it was decreasing. So it was pretty easy to realize it was an alternating series. In fact, maybe tomorrow we'll do that problem. So I think we can. I'll have to go back and look at it. And these are big points when we get to this part. Okay, here's this estimation theorem. And I'm going to rewrite it because that looks kind of complicated to me. So, but it's easy to apply. So I'm going to add this. I'm going to add a new page. And so here is the sum of my series. -1 to the n, b sub n is equal to 1 to infinity. So it's actually pretty easy. When you see something alternating, it's probably going to be an alternating series. But check to make sure the limit of b sub n goes to 0. Now that's with all of the terms there. Is that okay? This is the actual sum. This is a sum with an infinite number of terms. We're going to get the error. So what I'm going to do is, because I can't add up an infinite number of terms ever, right? I am going to add up maybe 3 terms, maybe 4 terms, something where I can add it up where it's finite. So it's s sub n. And then there are still some terms out there, aren't there? In fact, let's do that. Let's just do 3 terms. So I'm going to have b1 plus b2 plus b3. And then all the rest I'm going to ignore, okay? So what's going to happen to this? We call this R, and this is n. This is the nth term. This is R sub n plus 1. Or you can just call R sub n. It doesn't matter. That's the remaining terms. The remaining terms. And I'm going to add them all up. Yeah, it would be, but it won't. And it doesn't matter for this. We make that plus, let's make that minus, make that plus. Okay, now I have the alternating series. Okay? Is that okay? Now, if I want to find what the sum of the remaining terms is, if I want to solve for R sub n, this is called R sub n. I don't like R sub n plus 1. It's just too confusing. So R sub n, that's the sum of all the rest of them, is equal to the difference with the actual sum minus the sum, in this case, of what? How many terms do I have? Yeah, so it's all S3. Remember, that's a partial sum. Sorry, I'll slide it. Okay, and we put this in absolute value because I don't know which is bigger. Because you're adding some, you're taking some away. I don't know which is bigger. So the sum of the remaining terms is equal to the difference between the actual sum and the sum of the first three. And there's a theorem that says if this truly is an alternating series, then R sub n is less than or equal to the first discarded term, which would be what? If I went B3, what's the first term I didn't add in? B4. So this is less than or equal to the first discarded term. You'd have to add them up. Well, that's what's interesting with it, because they converge as fast. Usually you only need about 3. I don't know. I don't know how to clean it up yet. It's a mess. I may try, maybe during my lunch. First discarded term. The first one you throw away. So it's actually easy. And that's what all of this stuff says back here. Looks complicated. You have to have, this is all alternating series here, and it says that the remaining, which is the sum of all the remaining terms, is less than that first term you forget about. Discarded, neglected term, whatever. Okay, so let's look at the example. Find the sum of the series correct to 3 decimal places. Okay, I just want 3 decimal places. I'm going to need a calculator. So, by the way, n 0 factorial, by definition, is going to be equal to 1. We don't want it equal to 0. We want it equal to 1. So 0 factorial and 1 factorial are the same thing. So let's write out the terms. It's negative 1 to the 0 times 1 over 0 factorial. Then it's going to be what? Plus negative 1 to the first power, then it's 1 over 1 factorial. I'll do that in a second. Now, this only works for alternating series. If it doesn't alternate, you can't do this. Plus negative 1 squared, and then it's 1 over 2 factorial. It's not converging very fast, is it? Yes. And we'll do a whole lot more. And it's negative 1 cubed, and then it's times 1 over 3 factorial. Well, what's happening is these terms are getting smaller and smaller. So what is this going to be? This is going to be 1. This is minus 1, right? Plus 1 half. Then it's minus 1 over 3 factorial, so it's 1/6. Plus, then it's 7, not 7. It's 4 factorial. Okay, so it's 24. So it's getting small really quickly. I can't prove the theorem to you, but I'm just saying this is what it is. Then it's minus, and it's 5 times 24. What's that, 120? No, it's 120. Plus, we should know these because oh no, not sure. Okay, it's 1 over 720. Now, I'm going to need a calculator. What's 1 divided by 720? Let's change these all to decimals. That goes away. So that's 0.5. What's 1/6? 0.166. You see that that's going to change both the tenths and the hundredths place, right? I don't want to get out my big calculator. It takes too long. Okay, what's the next one? 1 over 24. You will need a calculator for this. 0.0416. Now, you guys, does this change the 10th place? Grant? Will that change the 10th place? No, unless there's a carry. Okay, minus 1 divided by 120. You can stop when it won't change the first 3 places. This is 0.0083. Well, for sure this isn't going to change the 10th. Well, yeah, but this got zeros in here. What's happening to each of these decimals? They're getting smaller. 1 divided by 720 is 0.0013. I want the first three to not change. That's still going to change the third one, isn't it? What's the next term? Minus 1 over, let's see, that was what? 3 factorial, 4 factorial, 5 factorial, 6 factorial, 7 factorial. You guys know where factorial is on your calculator? Okay, it's math. Oh, I got to go to probability 4. Okay, that is 1.984 times 10 to the negative fourth. What is that as a decimal? Remember? Remember how you go back? 4 places. 1, 2, 3, 4, 1984. That's correct. What's this going to do to the first 3 decimal places? Nothing. And the sum of all of them, so for n equal to 8, the sum of all of them, r sub 8 is going to be less than the first discarded term, which would be that one. So that's all you have to do is that they ask you to do it to, let's say they ask you, they won't ask you a number of places, but they may say do it for 4 terms. And then they'll say, what's the error on it? The error is less than that term. That's the first discarded one. So it's easy to do. They will say find the error such that it's that after the first, wait, 1, 2, 3, 4, 5, or 5 terms. And you'll have some in the homework that ask you to do that as well. They say stop here. What does the sum of all the remaining terms going to be less than? It's less than this value right here. That's your error. Because that tells you that the sum of this, if I go to right here, it's less than whatever that value is, and I forgot what it was. They will tell you what to pick. You could pick, this said this problem was 3 decimal places, but on the exam, it's too iffy, so they won't. They'll say, write out the first 3 terms, then what's the remaining, what's the error from the real value. Does that make sense? It's the real value. This is what they call the error. It's the alternating series estimation theorem. It's the error. Okay, Grant? So that if I add up all the rest of the terms, it's less than the actual value minus the sum of the first n terms. This is the real value. You're going to estimate it with 3 terms here. So this would be r sub 4. And you would look at b sub 4, that's all. So if b sub 4 is 0.00001, then that's how far off you are from the actual sum. So that's what they do in the biochemical, bioengineering stuff, is they use infinite series, but they only need 3 or 4 terms because the last ones just don't amount to anything. So when they get 3 or 4 terms, they're pretty close to the actual sum. Close enough. If I could build, if I even could make iPads with only that error, that would be good. The error rate is higher than that, I would think, on the iPad. Oh, I think they have a lot of defective ones out there that have to get returned. I've had the problem with the Kindles. Definitely had the problem with the Kindles. So um, that's just something that's interesting. Okay, that's the alternating series estimation theorem. That's all there is. Now, this next theorem is just tricky because you really have to think about it. First off, this is a definition. Okay? A series is said to be absolutely convergent. No, this is a definition. Then we're going to get to, you can call it a test if you want. You can use it for a test. I need it for the ratio test. That's the best one of all. Because you know what? I can't do factorials with anything I've got over there. I can't integrate a factorial. It's not geometric. So how am I going to do it? What am I going to compare it to? I can't compare a factorial to a p-series because I don't know how to do that. I don't know how 1 over n factorial compares to 1 over n. You have to know what the other one does. So you can't. So we have to have one last test. But before I get there, I have to define this. So a series is said to be absolutely convergent if you take the sum of the absolute values. If the sum of the absolute values converges, then my series is said to be absolutely convergent. So when you have series that have positive and negatives but not alternating, if you absolute value that series and that series converges, then the one with all those weird signs in it will also converge. But what if the absolute value does not converge? Does that really tell you much of anything? Well, let's look at this one. Does this converge? Absolutely. So you do this. You put it as an absolute value, negative 1 to the n minus 1 over n squared. N is equal to 1 to infinity. Well, that's equal to this. If this converges, then this series converges absolutely. Does that converge? Yes, by the p series. You have to say that. No, you know that this converges by the p series, therefore that converges absolutely, by definition. If you need it. Usually you don't need it. We need it for the ratio test. You'll see why in a second. Well, what about the alternating harmonic series? Does that converge? Absolutely. Oh, I'm sorry. Sorry. Alex, you're not going to know this. Unless you want to read the book. I think the book is hard to read on this. Because that's what I had to do. Long time ago. If you put this in absolute value, does the absolute value of that converge? If it does, then this is said to be absolutely convergent. If this absolute value converges, then the alternating series will converge, or whatever is in there that will converge. We could even look at some. We have a practice worksheet. Well, I'll get you another practice test before the test as well. What about the alternating harmonic series? Okay, what does this do, Grant? This is equal to what? 1 over n. Now, here's where this is confusing. Does this converge? No. You can say by p series, you can say it's harmonic. Everybody knows harmonic does not converge. Does not converge. But just because the absolute value didn't converge, does that mean the original series doesn't converge? Does this converge? Without the absolute value, does that converge? Yes, because it's the alternating harmonic series. So the problem is, it's wonderful. If the absolute value converges, then the original series converges. But if the absolute value does not converge, you know nothing about the original one. It could, might not. If the absolute value does not converge, we know nothing about the original series. It's just inconclusive. It tells me nothing. So we'll have to get another test. We have one more test. But its absolute value does not. So this is not absolutely convergent. This one does converge, but it's not absolutely convergent. If you say it's absolutely convergent, that means I can ignore the signs, and that new series will converge. And so that's what we're going to be doing with the ratio test, because I don't want to deal with that -1 issue. Okay, so if they tell you a series is absolutely convergent, then you know that the original one had to be convergent. So it's powerful in that way. If they tell you it's not absolutely convergent, then you know nothing about the original one. You're going to have to do something. And we're going to apply, mostly it's going to be alternating harmonic series. We're going to apply these tests when we add up an infinite number of terms in some series. And I think I said it right there. If a series is absolutely convergent, then the original series must also be convergent. However, if a series is convergent, it does not have to be absolutely convergent. Okay, so that's kind of important. It just might come back and haunt you. Okay, now for our favorite test of all. Okay, Matt? Oh, let's first do this. And then we're going to do the ratio test. And that's the last one. Now, if I write out some terms here, this is equal to the cosine of 1 over 1 squared plus the cosine of 2 over Now these are radians. Cosine of 3 over 3 squared. Oops. Does that alternate in sign? Well, let's look at it. All students take calc. So cosine is positive here, negative, negative, positive. These are the ones that are positive. So sine is positive in the second quadrant. Tangent is positive in the third. Cosine is positive in the fourth. All the other ones are negative in those quadrants, but all of them are positive in the first quadrant. Okay, this is 1 radian. So and you remember what a radian is? About 60 degrees, right? So 1 radian, that's positive. This is 2 radians. What's true with the cosine? Negative. That's 3 radians. Negative. And then it probably becomes positive again. So it does not alternate in sign, so I may not use the alternating series test. 3 times 60 is 180. Oh, it's a little less than that here. Still negative. And then that's negative. 3 radians is about 3 times 60. A little less than that, so you're still in the second quadrant. But it's still negative. I didn't even get into the third quadrant. And the next one's probably going to be will be in the third quadrant, so it's still going to be negative. So it doesn't alternate in sign, so I can't use that test. But I can use the absolute convergence test. If I can get it to converge absolutely, then it converges. So we will put this into absolute value. So the question is, does this converge? Are you okay if I just ignore the index? This is a pain to write, as you all agree. Now, this will take all of those cosines that are negative and make them positive. So this really looks like, I can compare it now. So this is certainly greater than 0. What is this smaller than? What's the biggest value cosine will ever be? So this is smaller than 1 over n squared. Right? This converges by the p-series. So then why would the absolute value converge? By what test? Comparison test. So it's a lot less writing than what you've done in other things in mathematics. But it also takes a lot more understanding. It's the only problem. Then you would say this convergent, this is absolutely convergent. Yes, you probably should. I'm going to tell you to be complete. Anytime I don't have an alternating series and you have negative terms, you'll look for absolute convergence then. And hopefully, usually most of the time it's going to work. Okay, so it's just a quick little test. It would be multiple choice most likely. Now the next one is free response. Multiple choice and free response. So you get this in both places. And this is what we call the ratio test. Actually, you kind of like this algebraically. I'm just going to ratio the end terms. So I'm going to take the ratio of the n plus 1 term to the nth term. I'm going to do the absolute value, so I'm going to get absolute convergence. And if this ratio here is smaller than 1, then my original series is absolutely convergent. I don't have to worry about the negative 1 to the n. So you'll get a lot of alternating signs. It doesn't really matter, but it gets rid of them. If the ratio of the n plus 1 term to the nth term is bigger than 1, then the series is divergent. Okay? This is a big point. That's what they did last year. It was the ratio test. 6 points on the free response question out of 9. So it's not hard. Once you practice it, you're going to say, oh, this is easy. But if this ratio here of the n plus 1 term to the nth term is 1, I know nothing. How do you know when to do this? I always go through the order there. I always take the limit of the sequence. I look for geometric series. Collapsing sum is the same as a p-series. You can find the value, though, but it's just like a p-series. So I look for p-series. If I can integrate, maybe I'll integrate. But integration, as you found in 510, was not easy, was it? No, it's not easy. And then you had the comparison test with the p-series. And then you had the limit comparison test, usually with the p-series. And then we had the alternating series. What do I do with factorials? That's where it is. Or n to the n. It's the factorials. So anytime you can't use the easy test, you have to do the ratio test. Now, I can do this with the regular test. I know the p-series. We can also do the ratio test. So what does this look like? So let's figure out how to do that. Grant? Okay, so let's do the summation of 1 over n squared. And let's do the ratio test. Now, the ratio test says I take the limit as n goes to infinity, and it's a sub n plus 1. Please, please put the absolute value in. I want to see how that compares to 1. If it's 1, guess what? The test fails. If this ratio is 1, I know nothing. If it's less than 1, it converges. It converges. And we already know it converges. If it's greater than 1, it diverges. But if it's equal to 1, I know nothing. Now, last year I graded this. They were kind. I said they should have been really mean about the absolute value because it's not right without it. I'm going to be mean about it, but they did take it without the absolute value last year. No, because there's only so many things that we can check for without going crazy, because we have like 800,000 tests to grade. I have to show you my pictures of that. Okay, so here's a sub n is 1 over n squared. There were about 850 of us in math. I don't know, but it's 8 days of grading. For 8 hours a day. Yes, we go to we sit in a convention center, and the big room is divided into little rooms. 8 to 5, with an hour for lunch. No, they pay you. Not a lot, but they pay you. Okay. So no, not that much, I wish. What is n plus 1? It's 1 over n plus 1 squared. It's like the limit comparison test over 1 over n. Now, why can't I get rid of absolute value? Why can't you? Because those are positive anyway, right? And then it's however you want to do it, but you understand that this is equal to the limit, because I just look at it. And it's n squared over n plus 1 squared. What is that limit? It's 1. So the ratio test fails. What do you think it's going to do for the harmonic series? Think it's going to fail? Fails there too. So the only way to do this one would be an integral test or knowing the p-series. So sometimes they fail. And you'll see when we get to Taylor polynomials, they fail at what we call these endpoints. Then you have to go back to other tests. Do you want me to do the harmonic one or just go to a real one? I'd rather go to the real one, but. So the harmonic is a sub n is 1 over n. Again, I'm going to ignore the negatives. So would the alternating harmonic work? No, because it's not absolutely convergent. So it's 1 over n plus 1, and it's 1 over n. So that's equal to the limit, as n goes to infinity, of n over n plus 1, which equals 1. It fails. Then when you get this, then you must go back and say, oh, it's the p-series, so that's why it fails. You have to get another test. Every single test fails in some situation. If it's not geometric, you can't use a geometric one. Some of you have been trying, but you can't. So let's go and do a real problem. These are kind of fun. A lot of algebra. And you learn a little bit more about your exponents, which you thought you knew. So there's my series. Now, what's your gut feeling? It's n cubed over 3 to the n. Which is going to be more powerful? 3 to the n is, and it's a lot more powerful. My gut feeling is a convergence. Right? I don't know what about this one? N to the n over n factorial. It's probably going to be divergent. Well, let's do the ratio test. Now, I write out the ratio test. You get your point for somehow convincing the reader that you know the ratio test. You get the first point there. So if you write it out like this, I believe, I'd have to go back to my notes, you will get a point for saying, oh, it's the ratio test. Because they're not going to tell you the ratio test. No, you're going to have to demonstrate you know what it is. Well, it's not that hard. So with the absolute value, what can I do with this -1 to the n? Just get rid of it. So it's the limit as n goes to infinity, and first I'm going to substitute this in. Now, I'll do this once this way, but it's n plus 1 cubed over 3 to the n plus 1. That's the n plus 1 term, divided by n cubed over 3 to the n. But you don't have to, you can skip this step. You can go right to the next step. Because how do we divide fractions? We multiply by the reciprocal. So instead, I can go right to this step, and you'll see me do that all the time. It to me is a waste of time to write it as that complex fraction. So it's the first one, n plus 1 cubed, over n, oops, 3 to the n. That one up. And instead of divided by that, I will multiply by, oops, that's n plus 1. Copy that wrong. Divided by was the same as multiplying by 3 to the n over n cubed. Are you okay with that? John, is that okay? All I did was, instead of saying divided by n cubed over 3 to the n, it's the same as multiplying by the reciprocal of that, which is 3 to the n over n cubed. And then I like to divide this up, or not divide it up, but to rewrite it so that things make a little more sense to me. I can do this without doing this, but I think it's easier for you. Let's put the factors that are similar together. N plus 1 cubed over n cubed times 3 to the n over 3 to the n plus 1. All I did was switch the denominators. Put this one over here and the other one over there. Sure, because if you have 1 over a times b, isn't that the same as 1 over b times a? Commutative property, right? Now, I'm going to rewrite this limit. This is all algebra from here on in. All I have to do is find the value. It's less than 1. That's the calculus, if you want to call it calculus. This is the same as this one. N plus 1 over n to the third power. Is that okay, Eric? Any problems with this? I rewrote that. If you have a over b, a to the n over b to the n, that's the same as a over b to the nth power. Then I'm going to take this 3 to the n, leave that alone. What's this 3 to the n plus 1? Times 3 to the first. Is that okay? I don't want to go too fast. I'm ready to move on, but are you guys ready? Okay, so this limit is going to give you what? 1. That's why we did those. So we did the sequences. And these will cancel out, so I'm left with 1 over 3, which is clearly less than 1. Therefore, converges by the ratio test. It's algebra. Just algebra. But once you do these, and please do them, you will have them on the exam. In fact, one time on the exam, you had to do, of the choices, they had 5 choices. You'll see that problem. You had to do the ratio test 5 times in that one problem. Or unless you had a better insight as to whether or not it was going to converge. Right, figure out which test to use. At least that's where I was. So that's why I put the list there. You first look to see if the limit of the sequence is 0, because if it's not 0, you're done. So I could do the limit of that sequence, n to the n over n factorial. If that's not 0, I'm done. Well, guess what? Do I know? I don't really know. I suspect n to the n is bigger. Okay, but I'm going to do the ratio test because we need practice with it anyway. But n to the n, if you graph this 2 ways, what's the second way? Oh, maybe that was my second way. I don't remember. Okay, let's do the ratio test. It's the limit as n goes to infinity of a sub n plus 1 over a sub n. Okay, so that's equal to the limit as n goes to infinity. Whoops, wrong one. I hate those. So it's n plus 1 to the n plus 1. Where you see n, you're going to put in n plus 1, and then this is n plus 1 factorial. I don't know if that's right. I can't get rid of it. Okay. Okay, now times, and then you have to divide by a sub n, which is that thing upside down. So it's n factorial over n to the n. And they're all positive, so forget the absolute sign. Let's put the factorials vertically. It's just easier to see. So it's the limit as n goes to infinity. And so let's see. It's n plus 1 to the n times n plus 1. We agree that's the same as the very first factor. I haven't done anything yet. I just did this one. N plus 1 to the n plus 1 is n plus 1 to the n times n plus 1 to the first. If the bases are the same, what do you do with the exponents? Add them. This is what I said. This is where you learn your exponents. Now let's put n to the n down here. And then I have what? Times, let's do blue color, n factorial. So what is n plus 1 factorial? Yes, it's n to the n. N plus 1 factorial. The first one's n plus 1. And then you subtract 1, so it's n. And you subtract 1 again, n minus 1. Subtract 1 again, n minus 2. What is this? It's n factorial. So n plus 1 factorial can be written as n plus 1 times n factorial. That's why we're doing the problem, because you will run into it. N plus 1 factorial is n plus 1. Then you take that n plus 1, subtract 1, so then it's n. Not to go down, n factorial always subtract 1. So if you have 5 factorial, it's 5 times 4 times 3 times 2. So you do 6 factorial, it's 6 times 5 factorial. Okay. There's going to be an interesting thing here that happens. What cancels? These guys go. What about n plus 1? That goes. And I'm left with this limit. Now, I'm going to take this limit and write it a little differently. I'm going to write it this way. That's that. I'm going to rewrite that again a little differently because I can divide the n into the n plus 1. Grant, you recognize this limit. I know you want to say it's 1. You have seen it. Well, careful. It's 1 plus 1 over n to the n. Now, remember that little problem with 1 being one of those borderline things. This is a problem because this is not 0. If it were 1 to the n, it would be 1. But it's not 0. This is just a little bit bigger than 0. So this is going towards 0, but that's going towards infinity. They're fighting. And I heard somebody say, was it Alex? It's E. So put this in your notebook. That's equal to E, which is clearly greater than 1 of divergence. You want me to graph it? That's E. Because this is not 1. If that were 1, I'd be okay. And if I had 1 plus 1 over n to the 100th power, the limit as n goes to infinity, that would go to infinity. This is that little border. that it behaves a little bit differently. So this is going to zero, but it never gets to zero. That's going to infinity, never gets to zero. So it's a tug of war. They're fighting each other. I want one wants to win, and infinity wants to win. And where do they end up working it out? They work it out at E. That's what it ends up being. If you graph it, you'll see it. Another version of this would be the limit, because while I'm here, I might as well do it. As n goes to 0 of 1 plus n to the 1 over n. That's equivalent. That's also E. That's going to 0, but that's going to infinity. You see that it's exactly the same limit? I think that's kind of cool. No? And that is the ratio test. Now you need to practice with these. We still have 10 minutes. Are there questions on 8.4? Or I can give you a little worksheet. Or how about the purple worksheet? The worksheet's hard. I think the book is easier. Yes. Well, you should have it today, but if you can't get it to me till tomorrow, I'll take it tomorrow. Yeah, they're over here. Yeah, one's pink, I think, and one's beige. The pink one's due today. Well, they're over there, too. They should be online. No, we're not splitting it, says. No, it says show that the series is convergent. This is alternating series. It's convergent by the alternating series test because clearly n over e to the n is decreasing. The limit of the sequence is 0, and it's alternating. So it converges by the alternating series test. And you should say, because b sub n is decreasing. They even wrote it in the problem last year, but students did not write it. So that was a problem. It's alternating, it's decreasing, and I would be really complete. The limit of b sub n is equal to 0 as n goes to infinity. It's conversion by the alternating series test. That's how you know. And then it says error. This is the only error besides the Taylor polynomial ones we're going to do. Has to be a decreasing series. So I want my error to be smaller than that. So all we have to do is write out terms. So n equals 1. It's negative 1 to the 0 times 1 over e to the 1 plus negative 1 to the first power, and then it's 2 over e squared. Now I'm going to need a calculator. Now let's see, that's plus, that's minus, so it's plus 3 over e cubed minus 4 over e to the 4th. What's the first discarded term? Where's my calculator? Anybody have one? Somebody has my calculator. Ah, there it is. What's 4 divided by e to the 4th? I have a feeling that's smaller than 0.01. You should add it up. No, he didn't do it. Oops, 4th. That's 0.0732, and 3 divided by e to the 3rd is 0.149, and then you should really add it up. It's still not small enough, is it? 0.1. I got to get that's 0.7. So it's plus 5 over e to the 5th. My guess is that's going to make it, that's be small enough. Nope, still not small enough. 0.033 minus 7 over e to the 7th plus 8 over, oh, sorry. You're right, I can't count. I was going to do odds or something. I'm not going to 0 very fast, is it? 6 over e to the 6th minus 7 over e to the 7th. Let me try that one. Thank you. And it's e to the seventh. That'll do it. 0.00638. I think they asked you to find the sum, so you have to use your calculator. Did they ask us for a sum? It says how many terms you need to add in order to find the sum. Oh, I need 7 terms, and after that, for sure it works. That's all they're asking. But then that's kind of vague. Is the question, is it 7 or is it 8? Or is it 6? So, will that affect it? That 6, there may be a carry there. So if I want to be safe, my first carry term would be the 8. I would keep the 7. But I don't know what the answer says in the book. Do you have to what? You might. But all you have to do is write out your terms, and you find the one that's smallest. Because the next one's going to be smaller yet. Oh, and it's time to go.